Welcome to this session on electrical test equipment. In today's lecture, we will go over various tools used in electrical diagnostics, including test lights, continuity testers, and logic probes. These tools are essential as electrical signals are not visible and need to be measured accurately. We will review essential tools for diagnosing electrical circuits which are invisible and often complex. Imagine a car's electrical system where diagnosing a faulty sensor without the right equipment would be challenging. Now coming on the importance of these test equipments. Since electrical signals cannot be seen or felt using test equipment, and that also right test equipment is crucial. A basic example is a 12-volt test light which is used to detect low voltage circuits in vehicles. Without such equipment, diagnostic or doing the troubleshooting of electrical issues would be a guesswork. As we know, these invisible electrical signals, for working with them, we have to rely on these test equipments to diagnose these issues. Take a small example. If a car headlights are not working, we can use a test light to check if power is reaching the headlight circuit. Without this tool, it could be very difficult for us to work on this system. So our first equipment, test light. It is a equipment used for getting the knowledge of the supply in a particular line. These test lights are simple and effective. A bulb with two wires is attached, commonly used to detect voltage in low voltage circuits like in cars. For instance, when troubleshooting a dead circuit in a car, a test light connected to ground and probing each circuit point can quickly confirm where the voltage is present and where it is not. Take another example. If a car tail lights do not work, we can use a 12-volt test light connected to the vehicle ground. By probing the wiring, we can check where the power is available and where it is not. If the light doesn't turn on at a specific point or location, we have likely found out where the circuit is open or damaged. It is essential to confirm your test equipment is working before starting diagnostics. Misdiagnosis often happens when test lights or meters are faulty. For example, a burned out bulb in a test light or a blown fuse in an emitter will yield inaccurate readings. Testing your equipment before use is critical. Imagine a scenario where a test light is burned out. You might think the circuit has no voltage, but in reality, the tool is faulty. For instance, before diagnosing a car's faulty horn, you would briefly test your test light on a known live circuit, like the vehicle battery, to ensure that it is working. Self-powered test light, known as continuity light. Self-powered test light or continuity lights include a built-in battery and can test if a wire or a component has continuity. However, these are not suitable for sensitive electronics, as their internal battery might damage electronic components. A self-power continuity light have a built-in battery to check for continuity. For example, if a car's brake light do not work, you could use a continuity light to see if there is an unbroken path from the brake switch to the light socket. However, avoid using it on delicate electronic circuit such as a vehicle ECU wiring, as the internal voltage could damage the sensitive components. LED test light. An LED test light is a low current alternative to a standard test light. For example, it draws just 0.025 amperes, making it safe for use on delicate electronic circuits without risking damage from excessive currents. This can be easily made using simple parts like an LED and a resistor. An LED test light is ideal for testing circuits without risking high current draws. For example, in troubleshooting a car airbag sensor circuit, an LED test light with low current, that is 0.025 amperes, cannot damage or won't harm the circuit. Standard test light might draw too much current, risking sensor damage, but an LED test light is safe for these applications. Coming on to logic probe. A logic probe detects voltage levels and indicates them with different lights. Red for high, that is a battery voltage, and green for low, that is ground. Additionally, it can detect voltage pulses, useful for checking components that switch states like sensors. A logic probe audible beep can also aid in diagnostic without needing to constantly look at the tool. A logic probe is used to identify high and low voltage points in a digital circuit. For example, in diagnosing a car fuel injector pulse, a logic probe connected to the injector connector can show if there is a high, it is a red light when it is powered, and a low green light when it is grounded. If the logic probe doesn't show a pulse, it suggests a wiring or an ECM issue. Now, how to use a logic probe? To use a logic probe, you first connect it to the battery for power and to the ground. It is then used to detect and indicate high and low voltage points. For instance, in diagnosing a relay, the logic probe can quickly tell if there's power at the control and load terminals and if the circuit ground is intact. A logic probe helps to check components that should alternate between high and low voltage. For example, when testing a crankshaft position sensor, the logic probe can show the pulse generated as the crankshaft rotates. The working sensor will produce a regular signal, helping to confirm its functionality. And also, there are certain, you can say, precautions that you have to use. Also, sorry for the disturbance. There are certain precautions to be taken while using these test equipments. So, the first caution is we have to be cautious with certain types of test lights and continuity tester around sensitive electronics. Testing a modern car's computer circuit with a standard continuity tester could lead to costly damage due to tester's internal voltage. An LED test light or a logic probe is safe for this application. Take another example. If we are testing a modern car's ABS or the airbag with a continuity tester that has its own battery, it could apply too much voltage and cause damage. In these cases, an LED test light or a high impedance multimeter is safer and won't harm the sensitive electronic components. So, finally, we have seen these three important components in case of automotive testing applications. Choosing the right test equipments and using it properly is a key to diagnosing electrical issues safely and accurately. From test lights to logic probes, each tool has a specific role, helping the technicians work more effectively, efficiently, and avoid damaging components. Therefore, getting the summaries of the today's lecture, we all know if we are performing troubleshooting for a particular vehicle using ammeter to measure starter current, a test light to check battery power, and a logic probe to check the relay signals can pin out the problem efficiently. I hope you have understood the significance of these test equipments. Use of proper test equipments at a proper location is very crucial. Please go through these slides of this lecture. Any student, if any doubt, can drop me email. Thank you for your attention.